Hi everybody. It's been a little bit since I've released my last video tutorial on FireWxPy, and in that time between then and now, I released FireWxPy version 1.5, and there's some new features in 1.5 as well as some upgrades and changes to existing features in FireWxPy 1.5, which we will address some of that today in this video. So in this video, we are going to use a combination of new and existing features to look at the sharp temperature gradient that's going from south to north across New York State. Now, I grew up in New York State, born and raised on Long Island, and I will say I have almost never seen a temperature gradient like this in my lifetime, where it's about 80 degrees in New York City and in the mid-20s with ice, with sleet and freezing rain along the northern tier and in the Adirondacks. So quite a temperature contrast. And we want to plot that in a few different ways. We want to plot that the RTMA temperature, as well as look at the 24-hour comparison of the RTMA temperature. We also want to look at some new types of plots in FireWxPy 1.5 and plot the observations, the METAR observations as a scatter plot, as well as take the METAR observations, grid them, and then plot the gridded METAR observations overlaid with some METAR observations, where you can then see the obs in a gridded format. I'm meteorologist Eric Drewitz. I'm also the developer of FireWxPy, and I work for the USDA U.S. Forest Service. So let's get started, shall we? So in our first, at the beginning, we are going to do our imports. So from FireWxPy, imports RTMA. Now don't get confused what I'm about to do from FireWxPy, import RTMA. So the difference between the lower and the uppercase, the lowercase is our RTMA module, which has all our graphics functions. The capital RTMA is the RTMA class of the data access module in FireWxPy. So in this case, since we're doing two RTMA plots and two different types of observations plots, we're downloading the same data set from the, we're downloading the RTMA data from the NCEP Nomads server, and we're downloading the METAR observations from the UCAR Thread server. Now, since we're making multiple plots off the same data set, it's best practice to download the data outside the function and pass it in, so you only download it once, to limit the amount of requests the servers that house the data get, so that you don't overwhelm the server. So that's the best practice when you're making several plots off the same data set, to limit the amount of requests. But the default is to do it all inside the function if you just want to do it, let's say, one time, or make multiple plots, but every plot is from a different data set. So to continue with our imports, we want to say from FireWxPy import obs, which is our obs class of the data access module. Now from FireWxPy import gridded obs, that's the class in our observations module that grids and plots the gridded data. From FireWxPy import scatter obs, that's the class in our observations module that plots the obs as a scatter plot. And then last but not least, since we need to use the UTC time as one of our inputs into our function that gets the RTMA data, we need our UTC time. So we're going to import from FireWxPy import plot creation time. Now we're going to run this cell. So I also let's restart the kernel. We need to restart the kernel, because one thing I did is I created a new test folder, and I'm working in a blank folder, essentially, where there's no folders and files that FireWxPy needs in order to work properly. And I want to show this because since it's my first video in a while, and I've started promoting my work on LinkedIn, which it's the first time I've used LinkedIn in 5 to 6 years, there's a much broader audience now and people who are probably watching these tutorials for the first time. So I'm going to simulate again a first-time user setup. So there's some shape files out there that FireWxPy uses, like the GAC and the PSA boundaries, things like that. Instead of having the users manually search the internet for these shape files and download them and file them to where they need to be in order for the software to work properly, I have FireWxPy do that all for you automatically. So I housed a lot of this stuff on my GitHub, all these shape files, I house them on my GitHub, and then we detect to see if the shape files are there. If not, we will download them and we will file them in the folders. So as you can see, we have these folders that are in there, and now all these files are in those folders. They have been downloaded, unzipped. You see we have our little print statement here that says we're setting you up since it's your first time. And if it's not your first time, there will be no print statement here, and then this would take a little shorter to do all the imports because we have everything set up. All it needs to do is just detect it, and then it'll move on rather than downloading it and setting it up. Okay, so now we need to get our data. So to do that, I'll first let's get our local time and our UTC time from our plot creation function. Or plot creation time function, I should say. Now, let's grab our METAR data. So DF, because we're going to be working with the pandas data frame, and our time. So since we have time a couple times, I don't want to use the same variable name twice. I'm going to call this ob time. And then we're going to say equals obs dot, we'll use our tab completion to show that to you, get METAR data, and it takes no arguments to be passed in. Next, we need to get our RTMA data. So DS for our data set, DS appended 24 for our data set from 24 hours prior to our data set, time 24, and that's equal to capital RTMA dot our tab completion, and then this takes two arguments. So the first argument is the region that we want to get our data. So it's CONUS, Alaska, or Hawaii as a string. Since New York's part of CONUS, we're going to do CONUS. Next, we need to pass in our UTC time. And so now we're going to run this cell and we're going to grab our data. So you're going to see a folder pop up on the left. That's going to be the folder that houses the METAR data. You're going to see a print statement that we grabbed the latest RTMA data as well as the data set 24 hours prior to the latest data set available of the RTMA data from the Nomads Open DAP. So our METAR folder's there with our METAR data, and now you can see we're trying to grab the 19Z data is not there yet. So we're going to grab the 18Z data from today and 18Z yesterday, so we have the data for our comparison. And now it's time for us to make our plots. So we'll make our RTMA plots first. So now we want lowercase RTMA dot. And now here we have our tab completion with all our different functions in the RTMA module. So anything that's blue here that says an F is the function. These are the things that you guys will be using in the RTMA module. So you see there's a bunch of different types of plots we can make. So in this example, we want to look at the temperature because that's where the really sharp gradient is. It's pretty cool to look at. So we're going to use our plot temperature. And now we're going to have to pass in a few different arguments. We're first going to have to set our state equal to New York. That could either be done with lowercase or uppercase. I'll keep it lowercase for this example. Then we need to set data equal to true. That is the switch that tells the function, hey, we're downloading the data from outside the function and we're going to pass it in. The default value is false, and when that's false, it'll download the data and do everything inside the function. Next, we need to pass in our data since we're downloading from outside. So we want to say ds equals ds, and then we want to say we need to pass in the time for our data set, so time equals time. Next, we're going to make our RTMA comparison plot. So we use our tab completion, 24-hour temperature comparison. And this one will look slightly different. We want to first start off with our state of New York. We also want to set our data equal to true because we're downloading it from outside to tell the function that's what we're doing. Now we want to set ds equal to ds, ds24 equal to ds24, time equals time, and then time 24 equals time 24. Next, we want to make our observation spot. So we'll make our scatter first. So scatter obs dot, and we'll use our tab completion. Plot temperature is what we want. And then this will also take a few optional arguments to pass in. So state equals New York, data equals true, df equals df, time equals ob time. And then last but not least, our gridded obs. And now we want to plot our temperature obs. So again, state equals New York. Then we want to say our data equals true. df equals df. Now we want to choose our mask. So the mask has to do with how far of a radius are we plotting for each ob site. So like it has to do with how much clutter do I want to see on the map. So for example, you could have observations that are very close to each other and it looks quite cluttered on the map. So we mask that to make the map look neater and less cluttered. So the default setting is 300,000, and that's for the CONUS. So we obviously want something smaller than that, a much smaller mask, since we want to have more ob sites because we're looking at a smaller area. So there's less chance that the obs are going to get all cluttered. Moreover, we're just plotting the number, the numerical value of the temperature observation. We're not plotting a huge station plot, you know, with the wind barb and the sky cover and all the different fields. So we could allow ourselves more clutter, if you will, or more ob sites. So that way we could have a more complete looking plot. So 300,000 is what the default is for CONUS. That looks good for CONUS. I played around with this in that other Jupyter Notebook file that you see there. And I found that the value of 30,000 works nicely for New York State. So 30,000 is our mask. Last but not least, we want to pass in our time as our ob time. And now we're going to run this. And so we're going to create our weather data directory, which is going to house all our weather data graphics. So all our graphics and our plots that we made from these functions in this cell are going to be in that directory. It's going to build the directory. It's going to create our images and save our images to the various paths in the directory. And this is going to take a few minutes. So we're going to pause the recording and we're going to come back when this has completed. Okay, so that finished running. So you can see we built our weather data parent directory, which houses all the graphics, and we built all the various branches that every image is stored in. And anytime, like let's say you're automating a script, and let's say you want to add something or change something, what FireWxPy will automatically build that new branch for whatever you added, for example. So also, if let's say these branches already were built, you wouldn't see all these print statements saying built, you know, and then the branch path. You would just see these print statements that say saved our graphic to this path in our directory. So let's go look at our directory. So we have our weather data directory. So we have observations and RTMA. We'll start with RTMA. So here's our RTMA temperature plot. And you can see we have large temperature contrast, you know, 80 to even 80 degrees down in the New York City area, upper 70s to 80 on Long Island, 82 it looks like down here in New Jersey, even 65, 70 up in Sullivan County, up by Monticello, but then up in Clinton County, 27, and they're getting freezing rain up there. You could see along central New York, from the, you know, basically the northern Hudson Valley to the capital region, and then through central New York, huge temperature gradient, going from like 60 degrees at the Pennsylvania New York border to 32 at Oswego, 80 in New York City to around like 35, 40 in Albany, to then low 20s up here in the Adirondacks. So that's our RTMA temperature Now let's look at our comparison. So this shows the temperature difference between today and the same time yesterday in a very large contrast. Now this is one thing that you also notice a change to the existing product. I changed the color table. So instead of it being blue to white to red, I did a blue to gray to a light gray to red, and it looks so much better. I really like this color table. Much cooler across the northern portion of New York, and then down through the portions of the Hudson Valley, into the northern Hudson Valley today compared to yesterday, but much warmer across Long Island, New York City, the lower Hudson Valley, getting into the western Hudson Valley and Sullivan County, as well as in Pennsylvania and northern New Jersey, much warmer today than yesterday. So quite a bit of a contrast here. Now let's look at our observations. So let's go back to our weather data parent directory and let's go to observations. So let's look at our scatter first. So here's METARs plotted as a scatter. So you can see much warmer down here, 70s to 80s down here, much cooler up here, 20s and 30s. And then last but not least, let's look at the gridded observations. And one thing about the gridded obs that I forgot to mention earlier, we use METPy's interpolate to grid function, so you could use a few different types of interpolation methods. The interpolation method will be shown here on the plot. The default I have is Cressman, but you have Cressman interpolation, Barnes, you have linear, nearest neighbor. There's a bunch of different options, so I recommend checking out METPy and checking out their documentation on the interpolate to grid, as well as I put it in my documentation to the different interpolation methods, because that's something you could change around at the beginning. I like Cressman the most, so I use Cressman as the default. But again, here's our gridded obs. 70s to 80s here, much more up there, much cooler up there, and then you can see our observations plotted throughout with 30,000 as a nice value for our mask, where we could see enough temperature values overlaid the gridded observations. So anyway, this also want to show how little coding it takes to create all these. You don't have to be a Python wizard to do this. If a meteorologist wanted to do this all from scratch and not use FireWxPy, you're talking about a few to several hundred lines of code at the least. So, this saves you a lot of work for a meteorologist to be able to recreate this and automate this. Basically, import what you need, download your data, and then call whatever functions you need to plot, and then pass whatever you want in. It gets easier the less you do, in the sense of, like, if I didn't want to download the data outside the function, it takes even less code to do that. But what the motivation is here, what would take several hundred lines of code to do this from scratch, now takes let's take a look. Show line numbers. So 6 lines here in our imports, 3 lines, 4 lines. So you're talking like 15 or so lines of code roughly. I'm not doing the counting in my head, rather than several hundred. So anyway, I hope you all enjoyed this video. If you like this video, please give it a thumbs up and feel free to subscribe for more FireWxPy tutorials.